All right, here we are on page 7. And number 1, we're supposed to find the missing length of the trapezoid base with a shorter base, B, legs L1 and L2. We should just get rid of that word. Height H and longer base B. All right, so here's basically what the figure is going to look like. So let's see what we have here. Number 1, we have a little base that we don't know. We've got a height of 24. Now that's important that we have a 24 here and we have a 24 over here. And notice that we have two right triangles. We have length 1 is 26 and length 2, or we could have put that on the other side, or 25. Now we did a Pythagorean triple here. A squared plus b squared equals c squared. A squared plus 24 squared equals 25 squared. Now if you remember the Pythagorean triple, we get that a is going to be a 7. 625 minus 576 gives us 49 and square root it. So we get 7 down here. 26, 24, and this, we're going to have a squared plus 24 squared equals 26 squared. Now you could recognize this as double of 12 and 13, which means this is double of a 5, or you could say, oh, a squared equals 676 minus 576 is 100, and a equals 10. So this is 10. So this is 10 and 7 down here, and it says the entire base down here is 47. So that must mean that we have 30 there, which is 30 there for the little b up here. So little b is 30. Whew! That took a little bit of work to do that one. Let's do number 2. So we have, again, like that. So we don't know what the little b is up here. The height is a 36. So we're going to draw these for the two triangles over here. L1 is a 39, and here's a 45 right here. And the base, this is going to be 150 total from here all the way over to there. Now you may recognize this as 3 times 12 and 3 times 13. So this is going to be 3 times 5, but let's do it officially. A squared plus 36 squared equals 39 squared. And we're going to have a squared equals 39 squared minus 36 squared on your calculator gives you a 225. So a is going to be 15. Okay, that's good. That's a 15 there. Here we have 36, 45. So we get a squared plus 36 squared equals 45 squared. A squared, punch that in your calculator, 45 squared minus 36 squared, and you are going to get 729 square root, and you get a to be 27. So you get 27 here. So here we have 15 and 27. That adds up to 42. So the rest of it has to be a 108. 150 minus those two numbers. So little b is a 108. Let's do number 3 down here low. 3. So we have this figure, and we have a height of 8, and then we have length 1 is 17, length 2 is 10, and this guy down here is going to be a 35 total for the big whole base. Yeah. All right. Here, do you recognize that Pythagorean triple? 8 blank and 17 should be 8 squared plus b squared equals 17 squared. And 289 minus 64 is 225. We get b is 15. And over here, a squared plus 8 squared equals 10 squared. 100 minus 64, a equals, let me see, that's 36. Square root is a 6. 6, 8, 10. So we have 6 and 15 is a 21, which means in the middle here, 35 minus 21 has to be about a 14. So this top base has to be 14. Ooh, look at this. Number 4, we were going to try L2. Okay, we better get some room here. All right, now we got some room. Let's do number 4, and we have this guy's 11, this guy's 50. Oh boy, height is 40, height is 40, and then L1 is 41, and L2, this is the guy we have to find. Okay, let's see what we can do. A 40 and a 41. Let's do a little a squared plus 40 squared equals 41 squared. We get a squared equals, if you take 41 squared minus 40 squared, you get 81. So a equals 9. So this guy's 9 right down here. Okay, and this guy is 11 right here. 9 and 11, that's 20. And so this guy over here has to be a 30. All right, so that's how we're going to find this guy right here is 30 squared plus 40 squared equals c squared. And that's going to be in this right triangle right here. So 30 squared, that's 900 plus 1600 equals c squared. C squared equals 2500 and square root. And yeah, this is a 3, 4, 5 triangle all times by 10. So that's a 50. Good. Number 5. We have 7 up here. The height is 12, and we don't know what the bottom base is though. So let's figure this out. We got a height of 12, and L1, this is a 15, and this is a 13. Well, 12, 13, hey, we know this one. This is going to be a 5. We can do it officially. 8 squared plus 12 squared equals 13 squared. But that's a Pythagorean triple. A squared equals 25 when you take 169 minus 144, and a equals a 5. That's good. So that's how we get that guy. What about this one over here? 12 squared plus b squared equals 15 squared. Some of you may be wondering, hey, how come sometimes the missing guy's an a and a b? It doesn't matter. Those two are the two different legs. You call one a, one b. Those don't matter. C is important, but in a squared plus b squared equals c squared, a and b can switch places. So we get 144 plus a b squared equals 225. Subtract them, and we get b equals b squared equals, looks like it is 81. And that gives us b equals 9. So that's a 9. So this whole base then is 5 plus 7 plus 9. That's a 21. Good deal. So number 6. Let's get some space again. Number 6. So we've got little base is 3, height is 7. Height is 7. Length 1 is 8 and length 2 is 9. So we've got to find the big base here. Okay, so here we have 7 squared plus b squared equals 9 squared. That's 81 minus 49. B squared equals 32. Ooh, b equals the square root of 32. That's square root of 16 times 2, that's 4 square roots of 2. Yuck. That's the right number, but now we're getting into square roots. Let's try it here with a 7 and an 8. 7 squared plus b squared equals 8 squared. B squared equals 64 minus 49 is 15. So b equals the square root of 15. Does that simplify? I don't think so. Square root of 15, and that's a 3. So this base is 4 square roots of 2 plus 3 plus the square root of 15. Well, that one wasn't very fun. All right, number 7. So the little base we don't know, but we get that the big base is 20. Okay, so that's the whole thing here. The height is 3, L1 is 5, and L2 is 6. Alrighty, we can do this. Oh, look at this one. This is 3 squared plus b squared equals 5 squared, but we know that that is a 3, 4, 5 triangle. That's a Pythagorean triple. That's going to be a 4 down there. 25 minus 9 is 16. Indeed. This one, let's do this. 3 squared plus b squared equals 6 squared. Now some of you may see this. We have a side half of the hypotenuse. That means we're in a 30, 60, 90 triangle. But let's double check to make sure we get that right pattern. But this should be like 3 square roots of 3. Let's double check. 36 minus 9, b squared equals 27. So when you take the square root of 27, that is the square root of 9 times 3 equals 3 square roots of 3. Yes, indeed, this is a 30, 60, 90 triangle. I didn't draw it very well, but here's your 30. There's your 60 up at the top. So this is 20 minus 4 is 16 minus, this is 16 minus 3 square roots of 3. And those can't combine. All right, last one, number 8. We have the little base is 15. The height is 7. L1 is 8. And L2, oh, looks like I got those backwards, but L2 is 11. And the height is 7. This one doesn't bode well at all. All right, we did that guy up here. This guy's a square root of 15. We know that. And this is 7 squared plus b squared equals 11 squared. 121 minus 49, b squared equals 72. So b equals, what's the square root of 72? That's 9 times 8. Oh, that can go down more. 36 times 2. That's 6 square roots of 2. So this is 6 square roots of 2. And the whole thing is, 15. That's 15 plus square root of 15 plus 6 square roots of 2. And that is the answer to number 8. Good. Let's get some space. Now right here, we are starting a new thing, right triangle trigonometry, where we're using sine is the opposite over hypotenuse, cosine is the adjacent over hypotenuse, and tangent is the opposite over the adjacent. We are all in degrees here. Now we need to make sure we note that every time we use a calculator to figure stuff out, we're going to be in degrees unless it comes in later trigonometry where it will be note radian. So if we're here and you can see that we're in degrees, yeah, we're going to use that. So this is just practicing solving these equations. Let's make sure we know how to do it. We'll do the first two longer and then we'll do the others pretty quickly. So first one, we got sine of 63. That comes out in a calculator. So sine of 63 equals x over 7. The way we get x by itself is to times both sides by 7. So in the calculator, we're going to take, first of all, let's make sure we're in degrees mode. We're down here, and you'll notice that that is a degree that we've got to hit. Now we can quit and do 7 times the sine of 63. So that's 6.23. That's what x is. X equals 6.23. And that's really all there is to these type of problems. Oh, 24. That was 237. 6.24. So if there's a number on the bottom here, it's going to multiply up there to get x by itself. So let's do number 2 and 3 just like that. Number 2 is going to be 3 times the cosine of 54. And it's 1.76. Number 3 is going to be 10 times the tangent of 38. 10 times the tangent of 38 degrees. Enter. 7.81. B equals 7.81. So we can keep going with this. Number 4 and number 5 are very similar. So number 4, we're going to take 11 times the sine of 43. We get 7.5. T equals 7.5. Number 5 is 13 times the cosine of 32. 13 times the cosine of 32. And we get 11.02. 11.02. Good. Now we want you to look at this one right here. Number 6 we've got to bring out and look at a little bit closer. If we have tangent of 47, this is a decimal number that is in your calculator, equals 35 over q. Notice we can't just times by 35 on both sides in order to get the answer. We need to times both sides by q, which will cancel it over here, and we get q times the tangent of 47 equals 35. In order to get q by itself, we now have to divide by the tangent of 47. And that's important. When the variable is on the bottom here, we have to divide this number, 35, divided by the tangent of 47 in order to get that q by itself on the top. So we're going to be taking 35 divided by the tangent of 47. And that gives us q is 32.64. 32.64. And so that shows us how to get it there. Good. So number 7, similar thing. We're going to take 32 divided by the sine of 36. 32 divided by the sine of 36. And we get 54.4. That's what x will equal. The next one, we're going to take 15, divide by the cosine of 12. 15 divided by the cosine of 12, and that equals 15.33. So A is 15.33. And the last one, B divided by the tangent of 36. And the last one, B, whoa, wait a second. To solve for B, we want to times by 10 times by 10. So really, can you see the difference between them? You're going to times that guy up there, but when this is on the bottom, you've got to divide. So yeah, times by 10. So the end answer is 10 times the tangent of 36. And that gives us 7.27. 7.27, that would equal the B. Good. Now let's look at this. Number 10 through 15, oh, they're a little bit different here. With number 10, let's put it over here. We have sine of alpha equals 2/7. Now if we take our calculator and we plug in 2 divided by 7, it gives us 0.2857 blah blah blah. Notice that there's a button on your calculator that is sine inverse. This is -1 up here. That is to the -1. That is sine inverse. In this case, it doesn't mean 1 over. It's the inverse function of sine. So we're going to take sine inverse of 2/7. So it puts that decimal in here. And what it does is it goes backwards from the decimal back to the angle. So this one is alpha is going to be 16.6 degrees. And just for good measure, you should note that if we take the sine of 16.6 degrees, it gives us 2/7. So that's where we're going backwards. So number 11, we're going to take, we've got to do the opposite of cosine of 2/3. So second cosine of 2/3. And that is 48.2 degrees. 48.2 degrees. Now notice we're solving for the angle now. All right, 11/10, and we're going to inverse tangent it. So second tangent of 11/10. And that is 47.7 degrees. Beta is 47.7 degrees. Number 13. 6/11, and then we're going to do the inverse sine. So second sine, 6/11, and this will give us the angle measure that the sine of this angle will be 6/11, so 33.1. So theta equals 33.1 degrees. Number 14 is going to be second cosine, so we're undoing cosine of 7/8. There we go. So 28.96 or 29 degrees. And last one, 12 over 21, and inverse tangent that. Inverse tangent of 12 divided by 21. And we get that that angle is 29.7 degrees. Pretty close to what we had before. So these were just solving. These were reviews of algebra and how to use the calculator to punch this out to be a decimal and go backwards with sine inverse or cosine inverse or tangent inverse to go back from the ratio back there. Good. So let's get us a little space. So for the following, from 16 down to 23, we're actually in a right triangle. And let's make sure we remember what Sohcahtoa is. We're going to put this up here. Sine of an angle, say theta down there, is going to equal the opposite over the hypotenuse. That's the A over the C. So that's where you get SOH if you've used this acronym. Sine is opposite over hypotenuse. Sine of an angle is the ratio that always exists opposite to the hypotenuse. Cosine of theta would be like the adjacent, the cozy side for cosine over the hypotenuse, and then the tangent of theta would be a over b, opposite over adjacent. Now we should note that if I were to say cosine of alpha, we now are referencing alpha as our angle, and the close side here is a over c. So, and that's true, the cosine of alpha is exactly the sine of theta. So we'll be able to use those to solve all of these things. So let's start. Number 16. We're going to have three different equations that will help us here. So we know that c is 13 and that theta is 26. So first of all, we know what alpha is. If theta is 26, then alpha is 64, because they have to add up to 90. So let's fill that one in right away. So we want to find b. So if we write down sine of theta equals a over 13. You see how we just followed that pattern? Sine of theta equals the opposite over the hypotenuse. And we know that theta is 26. So sine of 26 equals a over 13. We know how to do that. Let's punch in our calculator. 13 times the sine of 26. 13 times the sine of 26. And we get 5.7. So a is 5.7. If we want to find out b, we're going to use something like the cosine of 26 equals b over 13. So the cosine of theta equals b over 13. And we get, in the calculator, 13 times the cosine of 26, 13 times the cosine of 26 degrees, and we get 11.7. And you could actually go back through and see if 5.7 squared plus 11.7 squared actually got you 169. You'd be pretty doggone close. There's a little bit of error because we rounded, but it'll be right on. Okay, number 17. We know that alpha is 58, so let's do the sine of alpha would be b over c, and alpha is 58. So we have that equation that we can solve. And then if we do the cosine of 58, that's going to be a over c, so a over 5. So let's plug those in our calculator. 5 times the sine of 58, enter. So b is 4.24, and 5 times the cosine of 58, and we get 2.65, so 2.6. That's close. Now theta, these two have to add up to 90 degrees, so this is going to be a 32. Now notice we could have found these by doing the sine of 32 equals a over c. So we could have found a by the sine of 32, which is the exact same thing as the cosine of 58, equals a over 5. All right, let's keep going. Number 18. Ooh, this time we have a. So we know theta, okay, and we know a. So if we do sine of theta, which is 20, and then the sine is the opposite, 7, over the hypotenuse, which is c, that's good. Now notice if we did the cosine of 20, it gives us b over c. Well, that didn't help at all. We got two variables there, unless we use that c there, but we can use a different one. Do tangent of 20. Notice that the tangent of 20 is a, which is 7, over b. If you have one side and one angle, between the three of these you get the two equations that will solve it. These guys happen to be sine and cosine, but here tangent is going to be a little bit easier for us. So let's do this. Remember how we're going to solve for c on the bottom? That's when we multiply up here and divide that. So 7 divided by the sine of 20. 7 divided by the sine of 20. And we get, ooh, c is 20.5. And then we're going to do 7 divided by the tangent of 20. 7 divided by the tangent of 20. And what do we get here? 19.2. Whoa. That kind of makes sense. If you're a really small angle here, then this guy is almost as big as that one. And if theta is 20, then alpha is 70. Okay, let's do number 19. So this time we have b and alpha. So if we do sine of alpha, that's going to give us sine of alpha equals 12 over c. And alpha is 39. I keep forgetting to write that in. So sine of 39 is 12 over c. Cosine of 39, that will give us a over c. Yeah, that's got two variables in it. Let's try tangent of 39 again. And that gives us opposite, which is 12 over a. All right, let's plug these in. 12 divided by the sine of 39. 12 divided by the sine of 39 gives us 19.1. That's good. C is going to be 19.1. And a is 12 divided by the tangent of 39. 12 divided by tangent of 39. 14.8. And then theta would have to be, let me see, if that's 39 and it has to add up to 90, that's going to be a 51. Good. Let's get a little bit more space here. Okay, number 20. Oh, look, it gave us no angles at all. So we have to use the fact that we have a squared plus 15 squared equals 25 squared. Yeah, it didn't give us any angles, so we can't use sine, cosine, tangent just yet. Getting a, oh boy. So 625 minus 225 is 400. So a squared equals 400. Square root a equals 20. So a is 20. But how in the world are we going to get the angles? Well, if we know that a is 20 and this is 15 and this is 25. Oop, it's drawn a little bit weird. Let's get alpha. And notice you can do any of these. If you write sine of alpha equals 15 over 25, you're going to use inverse sine to undo this. But you could also have written cosine of alpha equals 20 over 25. And it would get you the same thing. Let's do both of those. So let's plug it in. We're going to do second sine of 15 divided by 25. And what does that give us? 36.9 degrees. Now if we did the other equation, we'd be using the inverse cosine of 20 over 25, and we better get the same thing. Look at that. Life is good. So alpha is indeed 36.9 degrees. Now from here we could create new equations for theta, but really we've got to just add these two up to 90. So subtract that from 90 and we get 53.1 degrees for theta. Now let's just try it for kicks. Theta, and do, I don't know, tangent of theta equals 20 over 15. We could use sine, cosine, or tangent, doesn't matter. Let's make sure this comes out to be 53.1, just to see if math is really true. Tangent inverse of 20 divided by 15, 53.1 degrees. Math is true. All right, let's go on and let's do the next one. Number 21, we have 13, 20, and what is c? So we have 13 squared plus 20 squared equals c squared. Oh, yuck. 169 plus 400 is 569. Square root of 569, I don't think that comes out very nice. Square root of 569. Yeah, so we could write it as 23.9 or the square root of 569. Either way, right there. In order to find these angles, we're going to have to do something like, we know A and B, which is 13 and 20. So if we're going to try to find, say, alpha or theta, tangent would be the easiest. Tangent of alpha equals 20 over 13. All right, let's plug that in. 20, tangent inverse of 20 divided by 13 is 56.97, so 57 degrees, right? So alpha is 57 degrees, and that means this guy is 33. Good. Number 22, let's try that one. We have a and c, so we got to do 21 squared plus b squared equals 67 squared. Pythagorean theorem. I think this is not going to come out too pretty. 67 squared minus 21 squared. Square root of that number Yeah, that's not too good. 63.6. I'm going to use a decimal on that guy. 63.6. But now, we have A is 21 and C is 67. If I'm going to try to find theta, sine of theta equals 21 over 67. I could do that one. Inverse sine of 21 divided by 67. And it gives me 18 degrees for theta, 18.3. So if we subtract that from 90, or subtract 90, we get the opposite of, 71.7 degrees. All right, last one, number 23. We get, I've forgotten how to do this one almost. We have alpha is 72 degrees, and we know that B is 57. So we can't do that. Oh, yeah, here's A, here's C. We can write that the sine of 72 equals 57 over C. Yeah, 57 divided by the sine of 72. 57 divided by the sine of 72. 59.9 is how big C is. 59.9. Let's write that down. 59.9. All right. And to get A, tangent of 72. Tangent of 72 equals 57 over A. So A divided by the tangent of 72, 57 divided by the tangent of 72. And we get something, much smaller, 18.5. And theta is 90 minus 72 is 18. Whew, that was a long one. That's right triangles and how we start using those guys to solve bigger problems.